Hello and welcome to part 2 of our two-dimensional grid videos. So yesterday we saw how to create a two-dimensional generic grid container where we implemented a function to access each element by a row and a column. We also created a helper function to show the grid. Let's see how do we use this container. Let's create a grid of integers of 3 rows and 5 columns and show this grid. Here I see I have a grid of 3 by 5, 3 rows and 5 columns, all initialized to 0. Now imagine we wanted all of this to be ones, for example. So one of the things I can do is to do a for loop just after I constructed my grid to set all the values to 1. Now I have all the values set to 1. This kind of use case of initializing a grid to initialize all the elements of a grid to a specific value is quite common. So it would be nice to have this already implemented in the constructor. So let's do it. Here we created a constructor that will accept rows, columns, but also an initial value. And for all the elements in our data vector that contains all the elements of the grid, it will assign the initial value to this element. Let's test it. Okay, so now we have a grid initialized to 1, all the elements initialized to 1, just using the constructor. Now imagine that I want a random number. What can I do is to use the random function from C standard library. So let's do it. Okay, here I have a random number for every element. But imagine I want a different random number for each element. So now I cannot use anymore this kind of constructor. I will need to go back to our for loop. So what can I do is to create another constructor that instead of accepting an initial value, it will accept a function to generate this initial value. Let's create this constructor. Here I create a constructor. Looks like the constructor we created with the initial value, but instead of accepting an initial value of type t, it accepts a function initializer that returns t and accepts void. So let's test it. Now here we see that we have a random value for each element, and instead of giving rand with the parenthesis that returns a value, I give the function rand. And we can use also lambdas. For example, imagine that we want a random number between 0 and 10. Now here I used the lambda function to return a number between 0 and 10, a random number between 0 and 10, and I used this function as the argument of my constructor to initialize an array of random numbers 0 and 10. And of course I can do this also with other types of data, for example chars. Let's try with chars. Here I have random letters from A to Z with this function that returns A plus a random number from 0 to 26. Another use case we can have is where the initial value depends on the row and the column. Imagine we want a grid 10 by 10 with each element being the row times the column. So let's create a constructor that the initializer function will have as arguments the row and the column. So let's now do our grid of integers 10 by 10, where each element is row times column. Okay, now we see an example where we can initialize our grid with an initializer function that will accept the row and the column as arguments. In the tic-tac-toe video, we create a structured position. Let's create something similar, a structure that we'll call index, to be able to index any element in the grid. Let's create a method for this index to check if this index is in range between two indexes. Meaning I will give an index minimum, an index maximum, and I want to check if the index is between those two indexes. One of the typical scenario would be where index min is 0, 0. Let's create an overload of this function is in range. Now, in our grid, we can have a method to return the max index. Let's create a method that returns the indexes of all the neighbors from a certain index. It will return the indexes as a vector. We will check up and down and left and right from our position if the index will be in range. If yes, we will put in the result. We see here also that if I is equal 0 and j is equal 0 will continue. It means that we are not adding our own position to the results. Let's test it. Here I created a grid 3 by 3 of strings that will show the index of each element. For example, here I have the first element 0, 0, 0, 1, and so on. So let's see if we choose to have the neighbors of 1, 1, we will see all of them 0, 0, 0, 1, 0, 2, 1, 0, 1, 2, 2, 0, 2, 1, 2, 2. Let's test it. Here I see that the neighbors of 1, 1 are indeed 0, 0, 0, 1, 0, 2, 1, 0, 1, 2, 2, 0, 2, 1, and 2, 2. Now let's test with 1, 0. So in 1, 0, I say 0, 0, 0, 1, 1, 1, 2, 0, and 2, 1. And let's test finally with, for example, 2, 2. And I have 1, 1, 1, 2, and 2, 1. Okay, so now we implemented our neighbor function that returns the index of all the neighbors. We are going to do in another video, we are going to make the game of life, and we are going to understand why this grid can be useful. Thanks a lot for watching, see you next video.